Well, the first of those groups that I'm going to look at are the bacteria. Well, let's ask ourselves the question, are bacteria forms of animal life or plant life, or neither? Well, in this case, some people will say they're neither because they're kind of in a kingdom all in and of themselves, but I still consider the bacteria as being single-celled forms of plant life. How important and how prevalent are they in the soil? They are extremely important and found in very high numbers in the soil. It's estimated that the live weight of bacteria in an acre 6 inches of soil. Now let's talk about an acre 6 inches of soil. An acre 6 inches is we're taking a surface area of an acre to a depth of 6 inches. That amount of soil would weigh approximately 2 million pounds. Well, in that 2 million pounds of topsoil, and it would be important that we're talking about the topsoil since that's where most of these organisms are going to live, in that top 6 inches of soil, there would be somewhere in the neighborhood of approximately 1,000 pounds of living bacterial organisms. Now that's an extremely large or high population of organisms when you consider that these are single-celled organisms which will obviously per organism would weigh very little. These bacteria that live in the soil can be either aerobic or they can be anaerobic. If an organism is aerobic, that simply means that it requires free oxygen. It's going to need to metabolize that free oxygen gas from the air in order to live and grow. If that bacterial organism were anaerobic, then of course that's just the opposite of the aerobic. That means that they really function best in the absence of free oxygen. They will typically multiply or reproduce much quicker as we get into conditions in the soil that would cause a lack of free oxygen exchange with the air above. Now, what types of conditions would those be? Well, if we have a soil that becomes waterlogged or a soil that has a crust on the surface or some characteristic like that, that's going to prevent the free exchange of gases in the soil. Because in the soil, we would expect oxygen to be diffusing in from the air above, and the carbon dioxide, which is building up in the soil air, would be diffusing out. So if we stop that movement of gases for some reason, they're not going to move through the solid parts of the soil. They're going to move through those pore spaces in the soil. And if those pore spaces become clogged or filled with water, then they're not going to be able to diffuse as rapidly or rapidly enough to prevent this anaerobic condition from developing or a lack of oxygen in the soil air. That obviously is not healthy for the growth of our crop plants or any other plants that might be existing in there, weeds or whatever, but some plants are much more tolerant of that low oxygen environment in the root zone than what other plants would be. However, one of the problems we run into is that there are certain types of bacterial organisms which are anaerobic that live in the soil that multiply and begin to reproduce in large enough numbers to cause consequences when we reach these anaerobic soil conditions due to a waterlogging or crustation or crusting on the soil surface or some type of effect that prevents that free exchange of gases. Well, there are many different types of bacteria that exist in the soil. Some of these are obviously beneficial and some are detrimental. Fortunately for us, from a quantity standpoint, there are many more beneficial bacteria because they are involved in this organic matter cycle and breaking down of organic material than there are the detrimental ones that are causing diseases and or volatilization of nutrients due to the anaerobic conditions that may be created in a soil at times.